All right, so we're going to talk about phase shift and vertical shift. Vertical shift, I mean, it's exactly what it sounds like. It is a shift of your function that is going to be up or down movement. Basically, what it's going to be is it's whatever your k value is. So whatever is being added on the outside of your function that is not inside the parentheses, or if there's no parentheses, it's just kind of added or subtracted on the outside of the function. So like exactly what you see right here in this example where I have 2 sine theta plus 1. It's this addition that's outside that I have right there. It's not inside any set of parentheses or anything. So that would be a vertical shift. What you're going to do is you're going to treat that as it is like a new x-axis. It's I don't know why I put new midline, but it should be new x-axis. It is the midline. So basically, if I'm looking at this function that I have right here, 2 sine theta plus 1, what I'm going to want to do is I'm going to go ahead, and my first step would be to go ahead and mark this. Actually, let me do this. I'm going to put this in black so I can kind of make it, or gray. I can kind of make it not part of my graph, but it's just kind of a boundary that I'm giving myself, kind of just giving myself a setup. I'm going to treat this just like I would have previously have treated this x-axis. I've taken my function and I've shifted it up 1. So now what I'm going to do is I'm going to kind of think about what does a sine function look like? Well, sine function with a positive a value is going to do this, right? So I always have a starting point and an ending point. So the starting point that I'm going to have right here for sine is always at the midline. It's not at a maximum. It's not at a minimum. It is always at the midline. So I'm going to go ahead and draw my sine starting right here at the midline, right here at 0, because I do not have any horizontal shifting of my function, which is the phase shift. We'll see that in a minute. But right now, this one has not been shifted left or right or anything like that. So I'm going to start right here at 0. And then I'm going to go whatever my period is. So let's think about that. What is the period of this function? The period is going to be 2 pi over b. Well, b here is whatever's being multiplied by the variable inside the sine function. So it's 2 pi over 1. So that means my period is 2 pi. If I go ahead and look, the x-axis here is not labeled. I need to kind of decide how I'm going to label this. You can kind of label it however you want. The most important thing is that the distance between each dash mark is equal. What I'm going to go ahead and do is I'm just going to go ahead and, I don't know, let me make this be pi right here. And I'm going to go ahead and make this be 2 pi. What I just did was so that every single tick mark is going to be pi over 4. Does it always need to go that way? Absolutely not. I could go pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi. You know, I could go by pi over 6s. I could go by pi over 3s. I could go by pi's. I can do whatever I want to make it work for the graph that I have. I just kind of decided to space it out a little bit here so I didn't need to use too much space. So like I said, that essentially makes it so that this would be pi over 4. So this would be pi over 2, 3 pi over 4 pi. This one would be 3 pi over 2 right here. So again, I'm just getting that because all I'm doing is just kind of figuring out if this is 2 pi and I'm dividing it into 8 pieces right here, that would be pi over 4. Okay, so I'm not trying to overcomplicate here. So my amplitude in this case is the a value, it's the absolute value, so that's going to be 2. So that means from the midline, I'm going to go up to and down to. So if I think about what that means, it means that I'm going to kind of have like a barrier, if you will. Like this is not part of the graph itself, but I'm just kind of giving myself a boundary. This way I don't go above it, I don't go outside of that, and I'm also going to go down to, and this way I don't go outside of that boundary either. Just kind of giving myself a little bit of guideline. So then at pi over 2 right here, or not pi over 2, why am I doing that? I'm going to go to 2 pi right here. I'm going to go ahead the whole length of my period. So if I'm starting here at 0, I need to go the entire length of my period to have a full cycle. So I'm going to end at 2 pi right here on my midline. Now, if you kind of look, and that's what we just did was the ending point, I need to do the middle here. So that's halfway between the starting point. That's halfway between the starting point and the ending point. So if I go halfway between 0 and 2 pi, that's at pi. So that's where I have another intercept. And then if I notice right here, halfway in between these first two intercepts, I have a maximum right here. So that means halfway in between these two intercepts, halfway between 0 and pi. Well, what's that? Halfway between 0 and pi would be pi divided by 2, pi over 2. So I'm going to have a maximum right there. And since I've already got this boundary right here at 3, because my amplitude is 2, that gets me that distance of 2 right here from my midline to my maximum. And then I'm going to go ahead and go right here, halfway between these two intercepts, I have a minimum. So halfway between pi and 2 pi over 2, I have a minimum right here. So I have this graph. That would be one period of my sine function where it's been shifted up vertically by just 1, and it has an amplitude of 2. It doesn't have any vertical reflections or anything like that, so that's all I've got. What's the domain of my function? Well, the domain of sine is going to always be negative infinity to infinity, unless it has been restricted for some reason and it's given you a shorter domain. The range of this function. Now, typically before now, it was always just whatever our amplitude was in a positive and negative. Well, that's not the case now because we got shifted up 1. So it's not -2 to 2. And I can see this right here on my graph. It goes from -1 to 3. Now, I encourage you to make sure that you're not only finding your range and a lot of these characteristics from just looking at the graph, because if you graph it wrong, then your answers are also going to be wrong. Think about it from a logical standpoint. The range is going to be that minimum to maximum. So if I've taken my minimum point, that's minimum point is found by taking your midline, whatever that is, and subtracting the amplitude. So in this particular case, I would do 1 minus 2, and then I would take the midline and I would add the amplitude. So that's always what it's been. It's just been plus or minus amplitude at this point in time because it's always been from the midline, and the midline has always been at y equals 0. But here, if I do 1 minus 2, I get -1. 1 plus 2, I get 3, which matches the range that I have here from -1 to 3. Okay, so now let's talk about phase shift. Phase shift is the opposite of whatever is in the place of h when b has been factored out. What the heck does that even mean? So what I'm saying here when I said that is right here. So it's the opposite of h whenever the b has been factored out. So let me just give you an example. If I'm looking at a function like this, if I just have y equals, I don't know, cosine 2 theta, no, I'm going to factor it out, plus pi, okay? And I have that. This right here, I can look at this and we should understand that, remember, phase shifts, it's what we've done this semester and this year actually has been anytime we've done a horizontal shift, remember it's on the inside of the function. It's the opposite of what you see. So in this case, it would be the part that's on the inside of the function. It's whatever's added or subtracted. And I do the opposite of what I see. So I should be able to look at this and I should say, oh, well, that's taking the function cosine 2 theta and I'm shifting it to the left pi. I do the opposite of what I see in there, right? Well, that's just kind of an example of what phase shift would be. You just kind of are shifting the graph left or right. Now, in this particular case, that's when the b is factored out. It's not always factored out like in these cases. It's not. So just the easy shortcut kind of way of doing this is it's the opposite of h over b. And so if I kind of look at what I have right here, you would normally go, do I have a GCF between 2x and -pi? And normally you go, no, I do not. But here, if I pull out a 2 from both of these, if I take 2x and divide it by 2, I'm left with x. And if I take -pi and divide that by 2, I have this. Now, if you redistribute that 2 back in, it equals exactly that, doesn't it? So I can look at this right now and I can say this right here, the opposite of that is my phase shift. I would be going right pi over 2 or positive pi over 2. That's what my phase shift is. Now, if you notice right here, if I do exactly what I just said, if I do the opposite of h and divide it by my b, so right here, opposite of h would be pi, divided by my b, that's 2. Look at that. It's the exact same thing. And that's because if you think about it, if all you're doing is taking that h that you have there and factoring out whatever the b is, all you're doing is dividing by that b, right? And then I'm saying the phase shift because it's the opposite of what I see. So opposite of h divided by b. That's what you've got. So let's try this one right here. If I do this one right here, my phase shift would just be the opposite of h, so negative pi, divided by my b, which is 2. This one, opposite of 24 pi, and I'm going to divide that by 8. Well, that reduces down, and that just gets me negative 3 pi. All right, opposite of h, so negative pi over 3, divided by negative 4. That's going to get me positive pi over 12. So that means on this one right here, the negative tells me we're moving left pi over 2. This negative 3 pi means that we're moving left 3 pi. And that means that I'm taking my entire function and literally just shifting the entire thing. Every single coordinate point shifts left or right, whatever that number is. So let's try this down here. So if I look at number 3, I just have 3 cosine, and then it's x minus pi over 4. So first, what is my a? A is 1, so my amplitude is 1. Okay, what is my b? B is 1. There's nothing being multiplied here that I can see, so therefore it's 1. It's not 0, because if it was 0, then the whole thing would be gone. Then I have my h. So h here is going to be pi over 4, because I'm dropping that into a negative thing there. It's the opposite. My k, it's a 0. That's on the outside of my function there. So a is 1, b is 1, h is pi over 4, and k is 0. So I don't need to move my graph up or down because there's no k value. So I'm going to go ahead and start wherever my phase shift is. That's what you're going to treat your phase shift as. It's a new starting point. So if we don't see it from here, again, it's the opposite of h. So positive pi over 4 divided by b, which is 1. So I'm going to come over here and look at my graph. And I'm going to go, oh, well, this is pi. And I have 4 little tick marks. So that means that this is pi over 4, pi over 2, and 3 pi over 4. So if I keep going, so 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. Hey, that's 3 pi over 2. 7 pi over 4. 8 pi over 4 is 2 pi. So there we go. I've labeled my x-axis right here. Okay. And now I'm going to go ahead and start at my phase shift, which is right here at pi over 4. Now let's think cosine with a positive a value looks like this. So it's going to start at a maximum. So I'm going to go, where's my amplitude? My amplitude is 1. So I'm going to start right here. Oops, sorry, phase shift. I'm going to start right here at pi over 4. In fact, I'm going to even kind of help give a little bit of a visual. This is not part of the graph itself. But it's just kind of, I'm treating it as, hey, this is like a new y-axis. Just like the midline gets treated as like a new x-axis, I'm going to treat this like a new y-axis, that I'm just taking my whole function, I'm going there. Now, previously when we graphed it, we would go, okay, my starting point right here at my maximum right here at 0, then I need to draw my next point, which would be my ending point, which is all the way over here. So that means I'm going to go from my starting point the entire length of the period. Well, the length of the period is 2 pi. So there's a couple ways you can do this, but let's kind of think about this. If I'm going from pi over 4 and I'm going 2 pi farther, I think the easiest way to do this is to kind of go, well, how many tick marks did 2 pi take? It took 8 tick marks. Or I've just moved my graph one more to the right. Let me go one more to the right of here. So that'll be right there at 9 pi over 4. So I'm going to have my stopping point right there at 9 pi over 4 and 1. That's going to be what I've got right there for that point. Okay, so now halfway in between there, see, I've got the starting point, I've got the ending point. Now I need to find like this halfway in between, which is our minimum point. So that's going to be at -1 on my y-axis, but where is that going to be on my x-axis? So it's halfway between the pi over 4 and the 9 pi over 4. Okay, easiest way to do this, again, there's 8 tick marks. So I'm going to cut it in half. I'm going to go to 4 of them. I'm going to go right here. And that would be -1 right here at 5 pi over 4. Okay. So I could do that. The other way to kind of do that, if I really wasn't too sure about what that place was, no, I'm not even going to go there. I'm just not going to go there. All right. Then I'm going to go right here between this one and this one. So, and I'm finding this midpoint here and this, I should say midpoint, intercept. So I'm going to go right here, 3 pi over 4, and right here, 7 pi over 4. I'm just finding that because they're halfway in between. If I'm looking right here, if I have 4 tick marks, it means I'm going to go 2. Okay? It's pretty straightforward what I'm trying to do here. And so now I've got that. All right, let's try this one last one right here. Okay. So with this one's a little bit more difficult because this one also has a period change. Okay, so first thing I need to do, find my phase shift. Phase shift, opposite of h, so negative pi over 2 divided by b, divided by 2. That's going to get me negative pi over 4. Oh, I didn't do my negative. So that means instead of going right pi over 4, I'm going to go left pi over 4. So let's look at our graph and see. All right, same thing. We're going by pi over 4s on this one. Okay, so let's do that. So right here, this is going to be my negative pi over 4 right here. So I'm just going to give myself, just like I said, a little starting point. This is where I'm going to be, okay? And then I got to figure out, well, where's my ending point going to be? So that's where I have to go phase shift, and I have to find the length of my period. So let's do that. My period is equal to 2 pi over b. So 2 pi over 2. So that means that my period is equal to just pi. So from that negative pi over 4, I have to go pi farther. Not saying I'm going to pi. I'm not going to the number pi. This is not where I'm going. I'm going the length of pi from negative pi over 4. So if we think about that, that just means that if this is negative 1/4, this would be 0, 1/4, 1/2, 3/4. That's where I'm going to go right there. If that's going 4 tick marks. So again, just kind of giving myself a little boundary. Again, these gray parts are not part of my actual graph. It's just kind of helping me to sketch it and make it look pretty. Because making it look pretty is kind of nice. All right, now sine. Again, sine starts at the midline, goes to a maximum, goes through the midline, comes back to a minimum, and goes to the midline again. So in this case, where's my midline? It's still my x-axis. We had no vertical shift on this one. So right here, I'm going to start at the midline on negative pi over 4, and I'm going to end on the midline right here at 3 pi over 4. All right, so then let's figure out what we've got going on in between there. So I just found this point and this point. Let's find this point. That's halfway in between my other intercepts. Well, that's going to put me right here. Okay, now let's find our maximum right up here. It's going to be halfway in between those two intercepts. And we have an amplitude of 1, so I'm going up to 1. And then we have a minimum right here, halfway in between these two intercepts. So it's going to be right here at -1. So I can see that one cycle of my graph going just like that. Now, be sure and also give coordinate points for these. And that's kind of why I was labeling the x-axis so that I could go ahead and give the five key points. So in this particular case, let's go ahead and give those. So the points that I would use on this one would be pi over 4 and 1, 3 pi over 4 and 0, 5 pi over 4 and -1, 7 pi over 4 and 0, and then this one, 9 pi over 4 and 1. Okay, and then I can come down here and I can go ahead and do these. And so this would be negative pi over 4 and 0. This would be 0 and 1. This one would be positive pi over 4 and 0. This one would be pi over 2 and negative 1. And this one would be 3 pi over 4 and 0. So that gets you the gist of it. So like I said, phase shift is a horizontal shift left or right. It's the opposite of your H divided by your B. You have your vertical shift. It's what's added on the outside, not inside parentheses. So notice here how this is inside parentheses. If I see addition and I don't see parentheses, it's a K value. It's a vertical shift. Okay? Hopefully that helps.